Hi everybody, this is Bill from AT Makers. It is a Sunday afternoon. I am finishing up something I started a week ago, which is frustrating. But I thought I'd give a quick update on a device that we're making for Jim Lubin. And I think it's going to be a device we're going to end up sharing with a lot of people. So I thought I'd walk through it again. I kind of gave the update of this before I wired it all up and soldered it all down. And I warned that it was going to be a messy spaghetti mess when we were done, and it is. But it does absolutely work, and I really like that. So I thought I'd walk through kind of how this works and show it in action, and then kind of explain what the next steps here are. I do have some questions for you guys. I have some questions about what you guys would want in terms of various stuff. So let's get started. So this is a microcontroller. It's a Feather. It happens to be a Bluetooth Feather, but it doesn't have to be. I'm not using the Bluetooth part of it. We could, but it doesn't really matter. It is powered right now by a USB cord here, and I'm gonna slide. Hello, Jeremy. I'm gonna slide everybody away here for a second. So I want to walk through kind of how this works. Over here on the right-hand side, you actually are going to have two inputs, two jacks like this one. I only have one hooked up right now, but I will show you what it does. Right now this one goes to one of our homemade switches, and on the other side, so there's two inputs. This is actually sip and puff in Jim's case. This one will be sip and that one will be puff. So these two will go to a jack and these two will go to a jack. And this will be connected to his sip and puff switch. On the other side here, there's actually six different outputs. So these two will be one, in this case, puff. These two will be a puff. These two will be a puff. These two will be a sip. These two will be a sip. And these two will be a sip. And the idea here is that this device can switch between these three outputs given these three inputs. And this actually has a lot of little weird nuances to it. Like the devices might be different voltages. They might be different currents, they might be different polarities. There's lots of things in here that we don't know. We just want to be able to switch the devices based on a long sip in this case. So long sip, or holding inward pressure on the sip switch for over a second or so, and we can change that amount, will actually make it cycle between the outputs. So the idea here in Jim's case is going to be his current Morse code reader, his new Morse code reader that he was trying to train on, and then his Tekla switch, which goes to his iPad, will be connected to sip and puff. And the idea will be for him to be able to switch between those without requiring an assistant. This is kind of a big deal. It's not specific to sip and puff. Any switches will work the same way here. I'm going to show that here in a second. Now, one of the reasons that some of you may say this already exists, there's a switch switcher. R.J. Cooper makes a good one. It's not ridiculously expensive. You're right, that exists, but there is a problem with it in Jim's case. So Jim actually tried that and couldn't get it to work because it introduces lag between when the button is pressed and when the signal is sent out this side. The way it does that, the reason is how it works. It senses a switch press, and then it closes a relay every time. So you'll hear a click every time that happens. In this case, that's not what we're doing. If you watch, I can actually, as fast as I can press this button, there's absolutely no lag. And if you listen, these are not making any relay sounds. The relays are not closing at all when this goes to that device. The reason is that it actually flows straight through to this device through the two relays, and this little device over here instead snoops on the signal, the sip signal, and watches for a long sip. So if I hold this down, I don't know if you guys could hear that or not, but it just switched to the next one. So try again real quiet. So after a second, actually every second you'll hear it. All right, so what that's doing is if it detects a press for over a second, it then switches to the next set of switches. So it goes 1, 2, 3, 1, 2, 3, 1, 2, 3. And it works, which is really cool. To do that, I'm using a current sensor down here. This is an inexpensive $5 to $10 breakout board. There are less expensive ways to do this, but this one works real well. There's less expensive microcontrollers I could use as well, but again, this one works real well. So the problem with this design is great. It's going to do exactly what Jim needs, and this is probably the board I will deliver to him as is. I will make a 3D printed enclosure for it and add the jacks that he needs. Then I've got some questions for the group about what to do with this long term. There are a couple different approaches we can take. So I will document this. It will be open source. Anybody can make it. I'll encourage the STEM programs to make these. But this is an awful lot of wiring. I'll show you the back of this just to kind of make this point. Every one of these is a solder point that I made to junction two wires together. And I haven't counted them all, but I would bet there's 50 of them. And that's a lot of things to do without making any errors. In fact, I made a big one when I did this. I actually wired all of these transistors in backwards. They are NPN transistors, and the order of the terminals is backwards from what I thought it was. So I wired them all in backwards, and I had to undo them all, and it took forever. And it really was quite a lot of work to get all this wiring correct. And I tend to think that this is beyond, doing this effectively is beyond most of the teams that we have. I'd like your opinion on that, especially those of you who are mentors for robotics teams. Do you think this is something that your team could do? Because there are kind of two other ways that we could go about this design. One is we could switch it to use the relay boards that are going to come out of Adafruit in the not too distant future. That would cut about a third of the wiring down off of this. But it's still got a significant amount. Another one would be to get circuit boards printed that had all the wiring already in place, so that all you'd have to do would be to solder down the through-hole components, solder down the relay, solder down the transistors, the resistors, the diodes. So you'd place them in and you'd solder them and you'd clip them off, but you wouldn't have any of these wires at all. And that would cut about 2/3 or 3/4 of the wiring off of this. And it would make it a lot easier. It'd be hard to mess up, right? You place things in the right place. There's a lot of soldering, but it's very, I think, doable. The cost of doing that would be about $4 a board, which I don't mind fronting that, getting, we could probably do it for less. I'm sure somebody could tell me how to do it for less, but it'd be about $4 a board for the first prototypes, and maybe we could get them a batch of 100 done for, $100 or $200 and drop that cost. But it would then require people to contact me, or somebody else at AT Makers in order to be able to do that. And that is a bottleneck that I don't really like. So, hello Tony Francisco. I'm interested in your opinions on that. A third option would be to actually have the boards made with the components on them. Find out what that would cost. I hesitate to do that because it makes me feel too much like a manufacturer in this space, where I really want to teach people to make these things themselves. So I'm curious what other people think on this one. I loved doing this. Surprisingly, I found it probably the way my wife feels about gardening, where it's almost therapeutic for me to go that heads down into soldering. But there's a lot of places where you can make a mistake on this. And I am very excited that it works, which is really cool. But I also need a name for it. Switch switcher is obviously taken, and it's not quite what this thing does. It's almost more of a switch spy or something, because it's actually spying on the signal that is passing through it here, and then acting accordingly. So one way or the other, we'll need a name, whether it's more productized or not. So Jim, maybe you're the one I should be asking for that input. I don't know if there are any. I don't see any questions. I see a hello from Jeremy and Tony's watching, and a couple other people are watching. But I probably will make a boring box for this. I thought about maybe making one in the shape of like an octopus because it's got 8 jacks. But I probably won't. I'll probably just make a simple box for this, and then wrap this up and have it ready to go when I go to California and bring me with me to Jim's. And then go ahead. I got a second project right here beneath this workbench. There is a suction device, a DeVilbiss portable suction device that I need to start taking apart because that's the other thing I have to do on my trip to California. So I'll be probably making a short video about that later in the week. But I am very excited that this works, right? There's no lag at all. And if you hold it down, it does switch to the next one. What I have it doing right now is that the SIP is monitoring it, but it's only changing the puffs switching. In other words, when you hold down the SIP a long time, it changes the puffs ones, but it doesn't change the SIPs one because I don't want to have 3 devices hooked up. But I did test that. It works fine. And I'm very happy about that. Any questions about how this works, let me know in the comments below. Let me know what you think about the circuit board printing and possibly actually populating it as well. Anybody from Adafruit has an idea on what the best way to go about making this more, but while still in a kit form or while still being done by the robotics team, get this out. I promise this is a device that lots of people are going to want. Right, the ability to switch what your switch is controlling, to change what your switch is controlling without an assistant is a very big thing, and I'm kind of glad we could make something that does it. If you guys have any questions, I'll look for them later. Bye.